Okay, this is Mr. Wyrick. I'm here to go over this logarithmic review for all these logs things for the test. On the first one, write the equation 2 to the 11th is 2048. That would be log base 2 of 2048 is equal to 11 because 2 to the 11th power equals 2048. On this one, log base 4 is 16 equals 2. That means that 4 squared is 16. Log base 6 of 1 over 216. 6 to the third would be 216. So to get 1 over 216, it's just a negative 3. On this one, 2 to the 4th power equals 16. So that's 4. Down here on this one, if we rewrite it as a single, these coefficients become exponents. And then I'm adding, so I'm just going to put them together because that'd be multiplying. That's log base b of v to the 6th, q to the 7th. On this one, we are subtracting, so that's dividing. That would be the log base 7 of 32 over 8, which would be the log base 7 of 4. If you can reduce, you always reduce. Number 7, expand the logarithmic expression. If you're doing this by yourself, the answer of this will be a multiple choice question on the test. So you need to make sure that you understand what expanding means. When you're doing these on the papers, I just expect it in at least 2 parts. This would be the log base 8 of 12. We're multiplying, so that would be plus. This exponent's going to become a coefficient, so that's 2 log base 8 of d. It could also be the log base 8 of d squared. Just make sure you understand equivalency on those. On this one, the only thing I'd really worry about is that dividing. So I would call this the log of 3x squared y to the 6th minus the log of z to the 5th. However, you could have the log of 3 plus 2 log of x plus 6 log of y minus 5 log of z. So it's really just understanding how each part could go, knowing what's going to be equivalent. On this one, that square root is going to be a 1/2 power. So this is 1/2 the log base 7 of 33 minus 1/2 the log base 7 of 24. Use the properties of logarithms to evaluate. Evaluate means you get a number answer. This would be, the 2 goes to the 64, so that's 64 squared. And then we would multiply that by 2. So we get 8,192. And we're doing the log base 2 of 8,192, which gives us 13. The answer here is 13. On this part, I'm not going to get the number answers. I'm just going to talk about setup, but each one of these should have a number answer, probably a decimal. This would be log base 7, because this is a base of 7, of 43 is equal to 7x. So you would get the log base 7 of 43, which would be a number, and then you would divide that by 7. On number 11, this is going to be a log base 3 of 24 is equal to x minus 1. So you get the log base 3 of 24 and then add 1 to it. That would give you your x. On this one, it's a logarithm. You rewrite it as an exponential. This is base 10. So 10 to the 1st power, which is just 10, equals 9x plus 4. You subtract 4, that'll give you 6. You divide that by 9, that's 6 over 9, which is 2/3 is equal to x, or 0.6 repeating. On this one, rather than move this to an exponent, it's easier to just divide it since it divides out evenly. That's the log of x is equal to a negative 2, so that's 10 to the negative 2 equals x. That's 1 over 100, or 0.01. Make sure you understand what's same and different between those. You get that fractional answer on the calculator. You need to know which multiple choice decimal is going to match up. On number 14, this is going to be, you're subtracting, you combine them, that's the log of 2x over 16 is equal to 0. But this is 10 to the 0 power. So 2x over 16 is equal to 1. 16 divided by 16 makes 1, so x is 8. On this one, same kind of thing, but it's a little weirder. That's 7x plus 1 over x minus 2. I would move this 1 to the other side, so it's 10 to the 1st power. That equals 10. In order to get rid of your fraction, you multiply by x minus 2 on both sides. So you get 7x plus 1 equals 10x minus 20. you get 3x is equal to 21, so x is 7. On all of these where it's asking for the domain and the vertical asymptote, those two are related. That vertical asymptote is that c value or h value, whatever you want to call it. So my vertical asymptote here, x equals 3 over 2. It's what would make into parentheses into 0. X equals a negative 1/4, x equals 2, x equals 3. And the domain, as related to that, is greater than but not equal to it. X is greater than 3 over 2. X is greater than 2. X is greater than 3. Okay? It's not going to be less than. It doesn't work that way. We flip this over onto the back. Write the expression as a single natural logarithm. Natural logarithms have the same rules. This is the ln of 5 squared, which is 25 times x to the 6th. This one is the natural logarithm of y to the 3rd over x to the 3rd. This lawnmower one, I've had so many people ask me about it, but it's really just t is equal to 3. So that's 5,500 natural logarithm of 9 times 3 plus 4. So you do the natural log of 31 and multiply it by 5,500. On this next one, same kind of thing, but natural logs are base e. So it's just like solving the logs on the front side. It's just, this would be e to the 3rd equals 4x plus 3. So get the number from this and then subtract 3 and divide the whole thing by 4. On this one, we're plus, so we're multiplying. That's a natural logarithm of 2x, so e to the 1st power equals 2x. Take e, divide it by 2. Number 21, you would subtract 8, so you get 13. You divide that by this 8, so you have e to the 2x is equal to, I don't know, 13 over 8. So this would be the natural logarithm of 13 over 8 equals 2x. Find out what this number is, divide it by 2. You can kind of do that in a step-by-step manner. On number 22, my setup, 1,000 times e to the kt equals 5202 on that 7 minutes. So 5202 equals 1,000 times e to the 7k. Divide both sides by 1,000, so that's e to the 7k is equal to 5.202. So this is going to be the natural logarithm of 5.202 is equal to 7k. Find this natural logarithm divided by 7. 12,000 account paying 6.5% interest compounded quarterly. You take your 6.5, make it 0.065, divide that by 4 because it's quarterly. And then how much money will he have after 3 years? I don't know. This one is like a really long decimal. It's like 0.013 something something something. Like go on the calculator. So like 125 or something like that. I'm not real sure. Put a 1 in front of that. If it's 3 years and we're compounding quarterly, that's going to be raised to the 12th, and you put your 12,000 out in front of that. There's my setup. I find my answer. Now don't trust what you get from putting this in. Actually divide your 0.065 by 4, but you get the idea. Number 24, 10,000, they compound your interest semi-annually. That means twice a year, and if it's 7%, that's 1.035. 3.5%. 1 year would just be, we're times 2, and here's my $10,000. Suppose you invest 900% at an annual rate, compounded continuously, that's 900. This is your PERT, P-E to the R-T. All right, I'll write that formula on the board. It's probably going to be only on like 2 questions, but make sure you know how to apply that formula. Otherwise, having the formula is worthless. This is 900 times e to the 0.068. I change it from a percent to a decimal, and then times 7.5 for the number of years. Number 26, in the account is given by this, and it doubled. Okay, if it doesn't give you amount of money to start with, just make one up. So here's $10, and we're going to multiply that by E to the annual rate, which is 7.5%, 0.075, and then that would be T, and I want to know when that's going to equal 20. Well, when you divide both sides out, you're going to get 2, and so this is going to be the natural logarithm of 2 equals 0.075 T. So take the natural logarithm of 2 divided by 0.075, and then that should give you your T value. It's going to be a bigger number because you're dividing by something very small. Number 27, you have $15,000. You plan to invest at 2.4% interest compounded quarterly. 2.4 divided by 4 is 0.6%. I have my 15,000. This is going to be to 4x, and I need 27,000. I'm going to divide this by 15,000. I'm going to rewrite it as a logarithm. Don't forget I need to divide by 4. So this is going to be the log base 1.006 of, 27 and 15 are both divisible by 3. That'd be 9 over 5. So 9 over 5 equals 4x. So get this number divided by 4. You have 10,000 you plan to invest at 3.6 compounded monthly. This is divided by 12, so 1.003. That's 10,000. Times 1.003 to the monthly, that'd be 12x, is equal to 15,000. So that's going to be the log base 1.003 of 15 over 10 would be 3 over 2. And that equals 12x. So you're going to need to divide by 12 to go from number of months to number of years. Then your 35,000 compounded continuously. This means that 40,000 is what it's going to be equal to, and that's 35,000 times E to the rate 0.012 times T. 40 divided by 35, because we take out all the zeros, that's 8 over 7. So this is the natural logarithm of 8 over 7 is equal to 0.012 T. You find this information, divide by that, and that should give you your number of years, amount of time. Remember, when it's compounded continuously, compounded quarterly, compounded monthly, you don't have to go an entire year, so you may not have to round up to a whole number to get that answer. If you have any other trouble with this, stop by, ask me at my desk, and hopefully this helps you out on the test.